Students, so today we will be doing the factoring enzyme activity. We have already done in my previous videos the concentration effect and the pH effect. So today we will be doing only dealing with the temperature. It's a detailed topic. First of all, understand there are two ways temperature affects enzyme activity. First, the way is increasing the temperature. Increasing the temperature. So how can we write this statement this way? So examiner can ask you by writing this or either this. So you should understand the both ways. So now if we want to divide, we can divide these two further. First, increasing the temperature. First of all, if you have studied chemistry, or you are in grade 9, grade 10, grade 11, there would be a question that should be raising in your minds, that how increasing temperature increases kinetic energy. So I will explain you. First, take an example of a ground. You have a football and there is another football over here. You kick this football gains energy. It has energy and it's moving. You give the kinetic energy by moving your leg. You kick this ball went and pushes this football. So the energy that this ball have, when it pushes this ball, the energy transferred to this ball which was stationary, which was not moving, and then this ball starts to move. Either it moves a little steps, but it moves. The energy transferred to this ball from this ball when it go and pushes it. Same is with the enzymes. How enzyme activity increases? Enzymes are mostly present in water or either blood or any other substance. Just say water. Enzymes are present in the water. As you increase the temperature, the water molecule starts to vibrate. These particles gain energy. How? These water particles go and pushes this water. The water particle starts moving and it pushes the enzyme. Same example with this. Heat pushes the water particles, you push the ball. This water particles go and pushes the enzymes. Same as when this ball you pushes the second football which was stationary. So when this enzyme goes and goes and goes, when this water particles pushes this enzyme, it's go and quickly attaches to its substrate, which was really far to it. So do you understand how it increases enzyme activity? Let's write down. Increasing temperature increases enzyme activity as it absorbs more kinetic energy and more quickly attaches and more quickly form enzyme substrate complex. So what do I mean by this sentence? Increasing temperature. When I increase temperature, enzyme activity increases. Enzyme activity increases as it absorbs more kinetic energy. How it absorbs more kinetic energy? This is an enzyme particle. When the water gains the energy by the heat molecules, this heat molecules pushes the water, and this water pushes the enzymes and pushes it towards its substrate. So this increases as it absorbs more kinetic energy. So this kinetic energy of the water particles passes or transfers to this enzyme molecule. And more quickly forms enzyme substrate complex. Just listen. This was water. Enzyme was here. Water was moving on its optimum level. It was not rushing or going quickly. It was just moving in a random motion. There was the substrate. It will take minutes minutes to travel over there. But when I increase the temperature, water started to move faster. So it pushes the enzyme quickly towards its substrate. I hope you all understand this concept. Let's talk about the another side of temperature. Every enzyme has its optimum range. It's same with all enzymes. The optimum range is 37, but we are not talking about hypothetical situations. We are talking about 10 to 40. If you reduce the temperature from 10, it affects enzyme activity. When you increase the temperature from 40, it affects enzyme activity. It increases the enzyme activity at certain level. Otherwise, there is another bad consequence that can happen by increasing the temperature from 40. Listen carefully. Enzyme or part, this is an enzyme. Take an example of enzyme pepsin, lipase, amylase, whatsoever. So this enzyme is made of protein. This enzyme is made of protein. These protein molecules are together because of hydrogen bonds. Otherwise, one enzyme, half of the enzyme was another part, was in the stomach, another enzyme part would be in the intestine. So why it is not that? Because they are kept tightly by and bond, which is called hydrogen bonds. When you increase the temperature, these hydrogen bonds starts to weaken. How it weakens, I tell you. When the water starts rushing, it pushes the enzyme. So this energy, the water molecules pushes. So it has kinetic energy. Water has kinetic energy, and it transfers that kinetic energy to these protein molecules that is inside the enzyme. So what happens? These bonds started to shake. These particles, these protein molecules started to shake. When they shake, the bonds between the particles weakens. That causes irregular shape of enzyme, or either enzyme can break one part here, one part here. So this is called denature. The shape of the enzyme changes. Enzyme is permanently denatured. It cannot be restored by any scientific method. So there are two versions of increasing temperature, two consequences. One, increasing kinetic energy at certain level. Like you can increase temperature 40, 41 increases enzyme activity, 42 increases enzyme activity, but you increase it further, then it starts to denature. So let's write increasing temperature of enzyme can weaken the hydrogen bonds between the protein molecules. So enzymes are made of protein molecules, that's final. So we can also say enzyme that can cause permanent denature. What I mean by permanent denature, now the enzyme shape is like this. How can a square shape in substrate can attaches to this irregular shape active site? Do you understand? If you have all a copy, I'm just erasing it in like 2 minutes. Alright. Let's talk about another various things. I told you there are two consequences of either increasing or decreasing. One was increasing the temperature. Second one is decreasing. Decreasing has only one way, only one consequence, and that consequence is also deteriorating or degradating. Sorry. So what is the fact in decreasing? First we write the heading, decreasing temperature from optimum range. So what is the optimum range? What do you mean? Better. So now you are decreasing the temperature from 10. The water was rushing. The enzyme was pushing towards the substrate. Here is the substrate, the water quickly jumping. Now the temperature is reduced. Water particles move slowly. This water now moves slowly. Here, then here, slowly. So this decreases the enzyme activity. If the temperature was high, this water would have taken 2 seconds to reach that substrate. But as we decrease the temperature, now that substrate would take like 20 minutes to reach that substrate. How? As the water has particles have more kinetic energy due to high temperature, it was moving fast. When I decrease the temperature, less kinetic energy, moving slowly, and with what is the result? Delay in products. Our cell, our hand cell, our skill cell needs quickly protein. Now a protein enzyme is moving slowly due to the decrease in temperature, which resulted in decrease in enzyme activity. So now to break down that protein substrate and to transport it, it will take time. It don't have any permanent changes or any permanent consequences, but this consequence is many concerning. So what we can write, decreasing enzyme activity, decreasing temperature, decreases enzyme activity as enzyme have less kinetic energy. Why I am saying enzymes have less kinetic energy, not the water? Because when the water pushes enzymes got kinetic energy. When water pushes, when I pushes a ball, it gains kinetic energy. Same as with enzyme. When this water pushes the enzyme, it gains kinetic energy. The enzyme gains kinetic energy. When the water don't pushes, enzyme don't have kinetic energy. So as enzymes have less kinetic energy, no pushing force causes delays in forming enzyme substrate complex. I hope you all understand this topic. I explained it in the most simplest way it was possible. I hope you enjoy my lectures. Thank you for watching my video.